Optimizing Baghouse Performance, a short video featuring Dr. Kevin Linfield. Baghouses, also known as fabric filters, are used to remove particulate from a gas stream and are a commonly used pollution control device. If designed and installed correctly, a baghouse can be exceptionally effective, collecting over 99.9% of particulate before it reaches the stack. Incorrect design, on the other hand, can lead to problems such as uneven flow, premature wear of bags, the use of more or larger fans, or particulate buildup that can threaten the structural integrity of supporting ductwork. Flow modeling is one of the most effective ways to ensure optimum baghouse design and performance. It is often done during the initial design phase, but can also be performed for an existing baghouse. Combining ICAC standards with manufacturing and final customer requirements, specific objectives of a baghouse study usually include ensuring that gas flow entering the inlet manifold in each compartment are well behaved, preventing gas velocities that are high enough to damage a bag via ash erosion, minimizing pressure losses throughout the baghouse, ensuring an equal flow split of gas and particulate to each compartment, with all compartments in service or with one out of service, ensuring proper mixing and interaction between any sorbent and gas, and minimizing ash deposition. The end result of the process is usually the design of flow control devices such as vanes and baffles that can optimize performance and avoid costly problems. Both physical and computational fluid dynamic modeling are useful tools in the analysis and optimization process. These methods can be used independently or, in some cases, together. In summary, a baghouse can be a powerful pollution control device, but its performance hinges greatly on local flow direction, velocity, temperature, and pressure. Ensuring that these factors are accounted for in your design can be a worthwhile investment that can save much in maintenance, energy, and labor costs. For more information on flow modeling, please contact Airflow Sciences. Thank you, and have a wonderful day.